We'll start in 2 minutes, all right? So, hello, am I audible?
Yes, please.
Thank you. And I hope my screen is visible. So I'll start now. So actually, I was traveling and I was not very well. So that is why the change of timing. And I think today's class will not be of 2 hours because the content which I have prepared is actually of not 2 hours. All right. So I hope that is not an issue. So last week also we didn't have class. So I'll start from where we left. We talked about data structures, and in that we talked about lists, tuples, um, sets, and dictionaries. Today we will see, we will talk about functions and also a little bit about modules and recursions. And when we talk about these two concepts in the next class, we will go back to dictionaries and we'll see how dictionaries and recursions combined together may help us give efficient code. All right. So first we will see. So today's class, in today's class, what we will see is we have talked about these things a little bit when we are talking about functions. So in functions, we saw that functions can be either user defined or inbuilt functions. So in today's class, we will see some of the inbuilt functions which are useful. But apart from that, there are a lot of functions which are inbuilt in Python, and you can go to the documentation of Python to see what are the other inbuilt functions and use them as and when you need them. All right. So teaching all the inbuilt function in a class is not possible. All right. So you see, first function which we will talk about, which is inbuilt in Python, is called absolute value function or ABS. So this is what in mathematics we know about absolute value. So if a variable say a has a value of minus 100 and you want to know the absolute value of that variable, you can just say ABS of a, sorry, ABS of a, and it will give you the absolute value of the variable, or yes, absolute value of the variable. All right. So this is a very simple function. Now there is a function called all. This function actually returns true. So this actually have a return value in boolean return value. It either returns true or it returns false. So when it returns true, when all the elements inside the iterable, so this term we have talked about what this iterable is, not in great details, but we have a little bit idea. An iterable is an object in which we can iterate. All right. So we have not gone into a depth in what is an iterable, but we have an idea what iterables are. So So lists are iterables. So if all the elements in the list are evaluating to true, what do I mean by evaluating to true? You will see. In that case, the value of that function will be, or the return value of that function will be true. So you see, suppose I have a list lst as 1 2 3 4 5, sorry, 5 and 5 again. All right. So you see all these numbers 1 2 3 4 5, these are non-zero numbers, and whenever there is any non-zero number, it is treated as true value in Python. All right. So when you apply this function all lst, you see lst is an iterable. All right, and all the elements in the iterable are actually true. In that case, you will get a value of true. All right, and in this example only, if you change one of the variables to 0, then you will get false. So this is very specific function, and you may require it some time, or you may not have a need to use this function. Since this function is there, that's why I have shown you. All right. Now this function is such defined that if you give it an empty iterable, suppose you have a list lst as this empty list, and when you say all lst, in this case it will actually give you true. So this is how the function is defined. So it is not why it is giving true and why it is giving false. This is how the all function is defined. Whenever you pass an empty iterable, so it may not only be list, it can also be tuple. So you have a tuple lst, not lst, let it be t is equals to, you can give lst also, but for understanding purposes I have given a different name. Just 1 minute. Yeah, I'm sorry for the disturbance. So I was talking about yes, tuples. So in case you have a tuple, just a minute. In case you have a tuple, then also it is an iterable. So you suppose you have the values as 1, 1, 2, 3, and 4, and when you see all t, then you will get true because all the elements over here evaluate to true. All right. If you have any doubt why these values are evaluating to true, you can ask me. All right. Now you can also have a boolean value inside a tuple or a list or anything set or dictionary, etc. Sets and dictionaries are also iterables. Huh? So uh, dictionaries are iterable. I'm not sure dictionary is an iterable, but set is an iterable. All right. So I have to check if dictionary is an iterable or not, but set is iterable. All right. So if you have a false value, so booleans you can have inside tuples. So I'm saying false is a value and true is a value. Then we have some numbers 2.2 comma 5.5, something like that, and then you again see all t. Then also this will give you false because one value is actually false. Either it is evaluating to false or false is there. Therefore, you are getting false. All right. I hope it is clear.
Can we try giving both as false or both as true?
Sorry,
Because,
tell me t is equals to.
the false to the first false to true and try again.
Yeah, sure, sure. This will evaluate to true. All right.
Okay.
So if the value is true or evaluates to true, then it will give true. All right. So this is how the function is defined. You may require this function at some point or the other, or you may not require. This is a function which is defined in Python. All right. So we have talked about dir function. It actually lists down all the attributes which is there for a object. All right. So you see, I'll define a list. Suppose lst is equals to, so we have lst actually. So let us use that lst. Oh, this is empty. All right, doesn't matter. So I have an empty list. Now I can say dir and I can pass that variable name, which is of the type list. You can check. So you can check also, you can check type lst and you will get list. So you are doing dir some list, and when you do that, then you will obtain all the attributes which are there for the for list. So you see, these are actually functions: append, clear, copy, count. We have seen some of these functions. Extend we have seen, insert we have seen, pop we have seen, remove we have seen, sort we have seen, append we have seen. And these are actually variables. We will talk about what these are when we go to objects. All right. So this is a function which lists down all the attributes which are related to a data type. So you can also do to a dictionary also. So suppose you have a dictionary, dic I'm saying that it's a dictionary, and these are the key value pairs inside the dictionary. It can be anything. We have talked about dictionary. If you have any doubt in dictionary, you can ask me now, or you can go back and see what it is. All right. So I'm saying this is a dictionary dic, and I'm saying dir dic, and it will list down all the attributes which are there for dictionary object. All right. So we have seen some of them. Get we have seen, items we have seen, key we have seen, pop we have seen, pop item we have seen. All right. Clear we have seen, copy we have seen. Now divmod. Divmod is actually a function which helps in mathematics. It actually you pass two arguments to this function. So I'll show you one example, then it will be more clear. So divmod, and you pass two numbers, say 9 comma 4. What it will do is it will divide 9 by 4, and it will return a tuple with the first value as the divisor. Oh, sorry, what should we call it? Factor, I guess. I am not actually saying it
Quotient.
correctly. Quotient, yes, thank you. Quotient and remainder. So it is 2 comma 1. All right. So this is what this function does. So 4 into 2 is 8, and 1 is the remainder. Thank you. All right. So now this function enumerate is very important function, and you may use this a lot of the time when you use for loop. So I'll show you one example where you might use it, or without also example you can understand where it is useful. So let me show you what enumerate does, and you can relate how you may use it. All right. So suppose we have a list which has the numbers, say anything, 23, 24, 23, 24, 25, 26, and 27. All right. So this is a list, and I'm saying for. Now I'll give two variables here. All right. So I'll say I comma j in enumerate, and I'll pass this list. All right. So this is actually a list. So I'll pass this list over here, number. And now I'll say colon, and let us print. I'll say I comma j. Let us do this first. All right. So see what it is doing. Enumerate actually returns a tuple. So when I'm saying I comma j, you may remember when we were talking about tuples that whenever you write I comma j without a bracket or with bracket, it doesn't matter. Python will understand that it is a tuple. So this actually enumerate is returning a tuple. The first element of the tuple is actually you can say starting point. So by default enumerate starts with 0. So it is saying 0 and the 0th element, which is 23. So it is saying 0, 23, 1, 24, 2, 25. So you see this is 25. So this is not actually index. This is the starting value is 0. That's why you are getting 0. You can change the starting value as well. So first let me show you what it does by changing the starting value. So when you pass one more argument to enumerate, let us say you are passing 9 you are passing, then it will start with 9. So it will start with 9, 23, 10, 24, 11, 25, 12, 26, 13, 27. So what enumerate is doing, it is actually iterating over an iterable object, as well as it is giving you a counter variable, somewhat like that. So in other languages like C++, Java, or other languages, if you wanted to do this and wanted to have a count of the loop, you would have to define another variable, say counter variable, and then you have to increment that variable inside the loop whenever the loop is executed. So that can be taken care of using enumerate function. So if you have any doubt, you ask me, because this is a very important function, and if you use this, it will make your life easier. You may not have to define. So suppose we had to do this, and you don't want to use enumerate, so in that case you will use range. All right, so and range only has only one variable j, and what I will do is I'll say I equals to 0, and over here I'll say I equals to I plus 1. All right, now these two will do the same thing. Sorry, what did I do wrong? List object cannot be interpreted as an integer. Range. All right, okay, so actually number is actually a list, so you did not write range over here. All right, so you see what are we doing? We are saying for j in numbers. So in first iteration j will be 23, in the second iteration j will be 24, and so on. And I, initially I is 0, and we are printing 0, then we are incrementing I by 1. So we are getting the same result which we got over here. So 0, 23, 1, 24, 2, 25, 3, 26, 4, 27. So you see, with less lines of code, you are getting the same result. So this is how enumerate helps in reducing the number of lines of code in your program. Any doubt? So the mistake which I made, you understood, na? I wrote range number. It shouldn't have been range number. That also, if you have any doubt why I erased range number, you can ask. I guess someone was asking something. I'm not able to hear you, ma'am. Can you speak a little loudly?
That's initialized to 8, but I value starts printing from 0 onwards.
Sorry?
I is initialized to 8, no sir, but I value starts printing from 0 onwards.
I is initialized to 0. This is 0 actually. This is not 8. I guess the number which you are seeing here is seeming as 0, but it is 8. But this is 0, not 8.
Okay, sir. Okay.
All right. Any more doubt? All right. So we'll move on to some more important functions. Filter is a very important function. All right. So you see, uh, first let me show you a way to use filter, then you will understand what filter is instead of me trying to understand what filter does. All right, so let us define a function called find positive number. So there will be a list, and if I pass that list to a function, what it will do is, no sorry, actually it will take a number and it will check if that number is positive or not. All right, so I'm just saying define positive. I'm saying the name of the function is positive, and it will take a number, and what it will do is it will actually check if the number is positive or not. So if number is greater than 0, then return, let me return the number itself. All right, if the number is positive, then we're returning the number, otherwise we're not returning the number. All right, otherwise we are returning none. All right, so this is a function. Any doubt in this function? This is a very simple function. It is just taking a number, and it is checking if the number is positive, and if it is positive, then it is returning the number, otherwise it is not returning anything. All right, now I'll make a list, say lst, and I'll say range, let me start by -10 to +10. So this has, actually this will not be a list, you have to cast it to list, but let it be. So we have an object lst, which is actually range -10 to 10. All right, now what I'm doing is I can show you what this is. So if you say lst, it will actually be an object which is a range object. If you want to convert this range object to list, you can do list list and then lst, then it will convert this object to a list, which is -10 to 9 actually, because it doesn't go till 10, it go one less than 9. Now see what filter does. I'll make a list which is positive list. So I'll have a list which is positive list, list, and I'll apply this function. All right. So what I'm doing is filter. This is the function which we are talking about, filter, and I'm saying this list which is lst. All right. So I'll pass the first argument as lst. Sorry, I'll pass the first argument as the function name. Function name is positive, and the second argument as the list which we have. So what is it? You see, in filter, the first argument is the function name itself. So the function name is positive, and the second argument is a list, or it can also be a tuple. It doesn't matter. No, I guess yes, it can be a tuple also. So we'll check if it is a tuple or not. I don't remember it, but let us see what it does with list. So this is a list, and this is a function. Now this function only takes a number, it doesn't take a list. But what filter will do is it will take one element at a time and pass it to positive. All right, so it will pass it to this function positive, and whenever it is true, then it will return that value. All right, so you see, let us convert this to list, and then you will be able to understand what it is doing. List, and we'll print this thing. Print positive list. Now you see what it is doing. You see what we did. We had a function which checks if a number is positive or not. If it is positive, it returns that number. Now filter is a function which actually has two arguments. The first argument is a function, and the second argument is actually a iterable. All right, so it applies that function to each element of that iterable. So it will apply this function to each element of the iterable. So it will apply this function to -10 first, then it will apply to -9, then it will apply to -8, -7, -6 up to 9. Now what this function does, it will return that number if it is positive. So these numbers will be discarded. Actually till 0 it will be discarded, because I am saying greater than equals to 0. If I had said, if I had done greater than equals to 0, then 0 would have come. Doesn't matter, that is not important. The important thing is we are not getting these numbers. We are only getting from 1 to 9. How it is doing? It is, this function is actually taking individual elements of the list and passing it to this function. So each element, so this function is being applied to individual element of that list. All right, so let me check if it is possible to do filter in tuples. I guess it is possible, so let us check. So t equals to, and I'll do the same thing over here. These are the numbers, and I'll say t. I guess this will work. Yeah, so it is working, but it returns a list. All right, so filter will, because we are making it a list. All right, so if we are not make it a list, then it will be an object. Yeah, it will be object. So you see how range returns a range object, filter is also returning a filter object. We have to convert it to list. So when we do that, then we'll get a list. All right, I guess I was not very clear. If I am not clear, please tell me. All right, because I have just, I'm not in very good sense of teaching right now. I was traveling, and my attention was somewhere else. Is this clear? If it is not clear, I'll just go back and I'll explain. Is this clear? I hope it is clear. Any doubt? All right, so you can also do that. If you have the computer right now, you can check what filter is doing. So it is actually applying this function to individual object of this iterable. All right, so you see we have a function called isInstance. Now isInstance actually, it checks if one object is of that class. What do I mean? So you see I have a tuple called t. I have defined a tuple over here which is t. Now isInstance is a function which will check if it is of that type or not. So what do I mean by that? You say is instance, and you first pass that object, and then say the type, which is tuple. And when you do, it will say true. Why true? Because this object, which is t, is of the type tuple. All right. Over here, if you say list instead of tuple, then it will give you a false value. Let us check. We are saying that it is list, then it will give you a false value. Similarly, if you say dictionary, so dictionary is actually written as dict in Python, then it will give you a false value. Why? Because t is actually not a dictionary. That's why you are getting false. All right. Now we have seen filter. Map is also very similar to filter. All right. Map is also very similar to filter. So what is filter doing actually? Filter is applying this to this. All right. Individual element at a time. Map will also do the same thing, but you see filter actually changes the list. So what do I mean by changing the list? You see, whenever this thing is none, so it is not saying none. So over here these elements are not none, it is just removed from the list altogether. But in the case of map, it will not be so. So let us show you what map is, then you will understand. First, make this point clear. When you have filter, and when this function is applied to this, whenever it is false, if it is false, it will remove, or whenever it is none, it will remove. So whenever this function returns false or it returns none, filter will remove that element from this list. All right, but map will not do so. Let us check what map is doing. So you see, I'll define a function. All right, say a function called square. So I'm squaring some numbers, def square, and it takes a number and it just squares it. So return num times num, or num power 2. It is same. All right. Now I will have a list which is numbers. So I guess I have a list called numbers. Yeah. So this is the list. Now I'll use this function called map, and the first argument of this function will be the function which we are trying to apply over here, which is square, and the second argument will be the iterable on which we are trying to apply this function over here. It is number. All right. Now when you do that, squ, okay, square, so I have written it here, square, sorry. And now let us convert it to list, then you will able to see what this is returning. You see what map is doing, it is doing the same thing what filter is doing, but it is applying this function over here. Now whenever this is false or it is none, then it will not remove the element, it will not reduce the number of elements in the list. Now why this is important, why these functions are important? Suppose you wanted to do this squaring the individual elements of the list, you would have to use for loop. So this filter, map, etc., these functions are giving you a way to overcome the use of for loop. So suppose in this case only you wanted to do square of a number using for loop, so you would have to define a list called squared. Let us say squared because we have something called square, and it will be an empty list. Now you will have to run a for loop for I in number, and then you have to say squared squared dot append, and it will be I power 2, sorry, power 2, and then at last you will have to print it. So print squard. So all these lines of code can be done with this code and the function definition, obviously. All right. So you may think that writing this is better than doing this function because it is difficult to interpret what this map is doing. But when you go to data science or data analytics, in that case you will have huge data in forms of tables, and in that case in a column you would want to apply some filter, or in that column you want to apply some function, say. So in that case these functions will be very important. You will not have to use for loops to iterate over all the elements of that column. In that case you just apply this function and say this is the function I want to apply, and this is the list, or it can be an iterable, so it will be a that column, on the column which you want to apply that function to, and in that case it will be very simple instead of doing a for loop. All right, I hope I made it clear why, not why, how map is better, not better, how map is important in Python. All right, any doubt? So you see map we have done, so there is something called reduce. All right, so you see what reduce is doing. So let me write the program first so it will be clear better. So you see I'll do without reduce, and then I'll do one code with reduce, and then you will see the difference between the code with reduce and a code without reduce. So I'll say product is equals to 1, and then I'll define a list 1 as 1, 2, 3, 4 and 5. All right, and then I'll say for I in list 1, and I'll say product is equals to product times I, and I'll print product. Now I'll do one more thing. So first let us see what this function, this block of code is doing. So what I want, I have a list and I want to calculate what is the product of all the numbers inside the list. So I have 1 into 2 into 3 into 4 into 5, which is 20. So that is what this block of code is trying to do. It is taking each element at a time inside the for loop, you see, for I in list 1, and then it is multiplying whatever the product of the initial iteration is, or the initial value of product is, to I. So first time we are having 1 into 1, then we are having 1 into 2 and 2 into 3 and so on. You get it, I guess. Now with reduce we will see how we are doing it. So this code will be with reduce. All right, so and one more thing, this function is actually you have to call a module to use this function. So we'll talk about what module is in today's class itself. For the time being you have to write this line of code from func tools, actually from func tools import reduce. All right, and then we'll define a function called def multiply. We'll have x comma y, will return x times y. All right, and we'll have product as reduce multiply comma that list 1, and we'll print this for understanding. Now you see what here what we are doing. You see we have defined a function called multiply. All right, and what this function does is it takes two values and it just returns the product of those two values. All right, so this is a very simple function. Now what reduce is doing is, you see, when we were applying map or filter, so it was applying that function, this function, to each element of this list or iterable. So it was applying square to the first element of number, then to the second element of the number, then to the third element of the number, then to the fourth element of the number, and so on. But what reduce will do is it will actually compute rolling, so it will do rolling computation. All right, what do I mean by rolling computation? You see, it will apply this multiply to the first two element of the list 1. All right, first two element is 1 into 2. Now it will take whatever the result is, which is 2, for these two. So when you apply multiply function to 1 comma 2, which will return 2, it will take that 2 and then multiply it with 3, so it will be 6. Now it will take that 6 and it will multiply with 4. Okay, so this multiply is actually multiplying, so reduce is not actually multiplying, it is taking the rolling computation. So first it is taking the first two elements, whatever the result is, it is taking the result, and then the next element, then whatever the computation is, the result of that computation is, and then the next element, and then whatever the result of that computation is to the next element. So this is what reduce is doing. Over here we are applying the function multiply, but reduce is actually doing rolling computation in that iterable. So this is a little bit tricky to understand, but I hope I was not very, I didn't make it confusing. So any doubt? So reduce is actually taking two elements at a time and then doing the rolling computation. No doubt? All right. Now we have seen built-in functions. So this is not the exhaustive list. There are many more functions. As and when you require, you have to go to the Python documentation and see what functions are inbuilt in Python, and you should try to use inbuilt function more and more. But whenever you need specific functions for your use cases, you should define your own functions as well. So those functions are called user defined functions, and we have talked about user defined functions. So this multiply is actually a user defined function which we have defined, called multiply. So we know what a user defined function is. All right, so I have given some advantages of user defined function, and I guess it is clear of what user defined function and its advantages are, but for the sake of completeness, I will say that you can have more flexibility when you have user defined function. Moreover, you will not repeat the code repeat the block of code in your program. So these are some of the advantages of user defined function. All right, so examples, we have seen a lot of user defined functions. So if you want, I can give you an example, otherwise we can skip this. All right, so this example I have taken as a calculator. So I guess I gave one program or problem in assignment 1 to make a calculator. So this is what actually this I have not written, I have taken it from somewhere, but this is good. So I didn't edit this code at all. All right, so what it has is, it has 4 user defined functions, and actually the problem is to make a calculator which can actually add, subtract, multiply and do division. So I have defined 4 functions. So not I have defined, so when I'm saying I have defined, whoever has written the code, that person has defined 4 functions. The first function is add, the second function is multiply, the third function is subtract and divide, and it says what it does. So the first is adding 2 numbers, the second is multiplying, the third is subtracting. So you must know that it subtract the second number from the first. All right, so this is important over here. And then division, so this also is important, it divides a by b. So this also you have to be clear when you take input from the user. It may not happen that the user wants b by a and you're returning a by b. So these things must be clear. All right, so these are 4 functions, and then it is saying that select one option, either you want to do addition, subtraction, multiplication or division. Whenever the user enters it, so the user sees this and then the input comes, enter a choice. So let me run this code. So it says enter a choice, I am saying 3. So when I am saying 3, so it's saying what is the first number, so I'll say 4, and what is the second number, it is 5. So the multiplication of 4 comma 5, so when I say 3 is actually multiplication, so 4 comma 5 is actually 4 into 5, which is 20. So this is a very simple thing. Now it also takes care of extreme cases. So if I say so over here it has 4 choices, 1 2 3 and 4. If I give any other choice, 5 6 7 or negative or any other thing, it will say invalid choice. All right, so this is a very simple example of showing how user defined function may be beneficial. So you see over here, these functions are defined once, but we can use it n number of times whenever you want it. So this is why we should always try to block our code. So whenever you have a big code and you can divide the code into chunks, it will be better for you, for your own understanding. You will know that this function does this, and if you have a flaw in that particular code, it will not propagate to others. So what do I mean by that is, if you know that the function which you have defined is correct, then when you face any difficulty in your whole program, you may not be required to go back to the function, because you know that function is working properly. Other part of the code may have some flaws. So this is also a very important thing you should remember when you are defining a function, because this helps a lot in blocking of code. So I'll give you one example of my real life. So I have a guide, and I went to the guide and we were discussing about our thesis problem, and I wrote one algorithm and showed to him. So he told me that, you see, you have written such a huge algorithm, but you can divide those algorithms in blocks, and when you do that, you can call one algorithm inside other algorithm, and that made my whole algorithm of 2 pages come to 1.5 page or 1 page. So thinking that way is more important. So changing the aspect in which you are thinking is more important. So these are very simple concepts. Making a function to add, you may think that, yeah, why is he is emphasizing on this so much, but when you solve bigger problems, larger problems, then these ideas of dividing your code into smaller blocks become very important later on. All right, and it will help simplify your code. Your code will not become messy and all. Excuse me, actually I'm not very well, huh? All right, so any doubt? No doubt?
No, so far no.
All right, so we'll go on to just let me drink some water. So we have talked about actually function arguments a little bit when we are talking about functions. All right, but there are some important things which I left and I should come back. That's why I am again discussing the topic of arguments. So we have seen function argument. So this function which we have defined. So I'll take this add. Now I have a function called add, and it has two arguments, a and b. All right. Now when you call this function, you have to pass that argument. We know that. I'm just doing it for completeness. So you see, we are passing two arguments, 3 and 4, and we have talked about actual arguments and formal arguments. If you don't recall, you can go back and see. So, and scope also, we have talked about scope of functions, and at length we have talked about what is the scope of the variable inside a function, outside of function, and you can use Python Tutor to clearly visualize other aspects of scope. All right, so this is a brief introduction of arguments, but one thing you have to make sure that this number of arguments which you are passing to a function should be same as the number of arguments which is there when you define the function. I mean to say, when you say add and you pass three values, I'm sorry, so it will give you an error because there is a mismatch in the number of arguments. You see, it's saying add takes two positional arguments but three were given. So you have to make this clear. But there are few things which you can do which will overcome this difficulty, and we'll see in today's class. All right, now default arguments. So you see, I guess we talked about print statement. So when we say print, and so this is not actually default, but I'm telling you what how I'll go back to default arguments. So when I say print and say good morning, all right, and I say just good morning, now it will give me good morning, and one more line I should write, print, let me write my name, Shubham. Now you see, when I do this, it will give a backslash n, so it starts at a new line. So the default argument of end, so there is some variable called end in print whose default value is \n. We can override that by changing the value of end. So over here I am actually changing the value of end to actually a space. So let me write a space over here, comma and space. So what I am doing is, this print function which is there in Python has a variable called end whose default value is \n, but we can override that when we are calling that function. All right, so it is not exactly default arguments, but we are seeing how we can override default arguments, but we'll get back to how we can define default arguments. But let's see what it is doing. So we have talked about this in our earlier classes. You see, I have overwritten the default value of end by giving a value of end. All right, so the default value of end is actually \n. So I have defined it in a reverse way. Now coming back, how you can define some default arguments. So you see, I am defining a function called greet. So it will greet me, good morning Shubham. All right, so first I'll take let me take name and then take message. All right, and it will just print hello, or yeah, it will just print hello, comma, and it will take name, hello name, and comma, the greeting, so message. All right, so this is a very simple function which prints hello, whatever the name is. I have to say f because it is an f string. Now I hope you remember what f string is. So it is saying hello, whatever the value of name will come here, and whatever the value of message will come over here. All right, so let me call this function. So I'll say greet, 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 and I'll pass Shubham, and then I'll pass good morning. Now when I do this, so you will have hello Shubham, good morning. All right, now what you want is, you want to define some default value of the message, and if the user doesn't pass some value to that second argument, the default value will be taken. So I'll change the default value. So I'll define some default value of message by giving a value at the function definition itself. So I'm saying the default value is good night. All right, I have defined this, I have executed this. So this function is there in the memory, and when I call this greet Shubham comma good morning, it will print hello Shubham good morning. Now in the same case, but I'll not pass the second value. In this case, the default value of message will be taken hello Shubham good night. All right, so this is what a default argument is. I hope it was clear. So this is how you can define default argument, but you should be cautious. So there is one word of caution here. You see, this function, if you had defined message first and then the name, this will be a problem. Why this will be a problem? You see, this way you have defined. Now what are you doing is, so let me execute this. So what is the error? Non-default argument. Yeah, so this is the error. Actually this is what I was trying to tell you. So you see what is the error here. If you call greet with this Shubham and no other value, what it will do is, it will change the value of message to Shubham and name will not be there. So always default arguments are followed at the last. So default arguments are always at the end of the function. So in the parenthesis, default arguments will be at the end instead of, so no arguments will be there after default argument. This is what I mean when I am trying to explain over here. All right, so this should be taken care of. Always default argument should be at the rightmost part of the function definition. All right, so is this clear? Any doubt?
Can we define default for name also? Is
Yeah,
it
sure.
possible
Yes,
to
yes,
do?
yes, yes, yes. So I can do Ram. Now, if you doesn't give anything and say greet, then you'll get hello Ram, good night. All right.
Okay. Okay. Thanks.
Now there is something called keyword arguments. Achha, let us take a break of 5 minutes and then we'll come back at 11:27 maybe. Okay. So not 11, 7:27. All right. So by the way, I think I'm not very clear today in the class. Is it so? Because I'm not very well prepared today, so I apologize for that. Okay, we'll meet at 7:27. Yes, you were saying something.
No, no issues so far, so good. I mean, not bad.
Okay, thank you. So I hope everybody is back. So let us see what is keyword arguments. So you see, we have talked about dictionaries. So this is very similar to dictionaries, but these are not actually dictionaries. So sometimes what you want is you want to pass some values to a function or the arguments such that it is it actually is related to some keywords. So let me define some function and then you will understand what it is. So it is so I'll again say greet, and whenever you want to use keyword arguments you have to write it this way only. Okay, so double asterisk KW ARGS, it is actually keyword arguments, KW keyword arguments, and it will have if this is true. So I'll say if keyword arguments is true, so it means that if keyword argument is present, so if it is present then it will evaluate to true. So this is of Python. All right, so if it has a value, then it will evaluate to true, otherwise it will evaluate to false. So if it is true, then I'll print. So what I will print, I'll come back. Let me say what is the how are we calling this greet. So when I'm calling greet, I am passing keyword, so key value pairs. It is not similar, it is similar to dictionary but not dictionary. Why, you will see. You see, I'll say name Shubham, and message is actually good morning. Now you see in dictionary we had to write colon, but over here we are writing equal to. So what are we doing is actually we are passing these. This is one key value pair to this, and this is also a key value pairs. So we can pass as many key value pairs as we want to this. All right, and now we can use it. So we can say hello. So I'll use f string over here. I hope you are clear of what f string is. If not, then you can ask me now. Hello. I'll say, okay, so I should use format. I don't know if it will work with keyword or not. Sorry, f string or not. I'll use format, and I'll say dot format. The first will be KWARGS name, and the second will be KWARGS message. So you see we are calling it similar to how we will call a dictionary. So whenever you want to call a dictionary, so this will be the name of the dictionary, and we'll pass the key in that dictionary and we'll get the value of the dictionary. So it is very similar. So this will also be the dictionary name, and in box bracket we'll pass the key of that inside whatever the dictionary is, and then we'll get the value. So it is very similar. So this is how we'll get the value of the key with the name KWARGS dictionary, but this is not a dictionary, huh? So this is little bit different. So we'll get hello, and the 0 is here. This is Shubham, because for name the value is Shubham, and for message the value is good morning. Now I guess this will work with f string also. I didn't do it, but it will work. So I'll say f over here, and this will be keyword name over here, and keyword message, this one will come over here, and this will work. Yeah, so what I did over here is, so I used f string. So these are same code, just I used format over here and f string over here. And first I'm saying whatever KWARGS name is, whatever KWARGS message is. So over here you must know what is the key. If you don't know the key, then it is difficult to use this keyword arguments. So this is important over here. All right. Any doubt?
So in this case, we can also swap this name and message front and back, right? Even then
Yeah, yeah.
the message.
Yes. It is just similar to dictionary. So you can check, it will work. All right.
Okay.
Now there is something called arbitrary arguments. You see over here also, when we are saying KWARGS, we did not know the number of arguments the user is passing, but we had to know the key. Otherwise, how will you get the value of that keyword? Sorry, not keyword, the argument. But when you use arbitrary argument, in that case you can you don't need to know the keywords because there is no key value pairs. It can give as many number of arguments as the user wants. So let me define this function again, dev greet, and this is how you have to write this argument. So it can be any name, but you have to give asterisk. So over here also it can be any name. It can be any name. It can be k, but you have to do two asterisks there. All right. So this is important. It can be any name, just two asterisks should be there, and you can check it will. Okay. Name keyword.
Near
Okay.
if.
Yes, if yes, it will work. So two asterisks should be there. That is important. Otherwise, you can give any name. Over here also, I had written KWARGS because we were talking about KWARGS, but you can give any name. The only important thing is you have to give two asterisks, and in arbitrary argument you have to give one asterisk. So you can give any name. I'm saying a name. All right, and I'll say print. So you will see what name is. So I'm saying print name. It is not important, but I'll just show you what was passed in name. Now, since we don't know the number of argument passed in name, so let us use a for loop. So it is for our convenience. So I'm saying for I in name. What should we do? We should say print hello. I'll do f string f comma whatever the name is. So I. All right. And now I'll say greet, and I'll pass few names. So I'll say Shubham, then I'll say Ram Prakash. Sorry. Okay. Now I'll say Arjun, and you see it will work. So when we passed this, it is passing as a tuple. And if you remember, when we are talking about tuples, we mentioned it that whenever this when we pass one value to the other function, it is generally passed as tuple. Why? Because we don't want the value of that arguments to change somehow. That is why over here we see it is passing as a tuple. All right. So a tuple is being passed to this variable called asterisk name, and this is what asterisk name is. You see, name is actually this. Now what for loop is doing, it is taking individual elements of that name. So first it is saying hello Shubham, hello Ram Prakash, hello Arjun. So this is how this will work. You can pass as many arguments as you want. You can also check what will it do when it has no arguments in it. So you can check that also. So suppose I did not pass any argument. Now it will have nothing, and for loop will not work because it has no elements, so it will not give an error. So if you can pass 0 arguments, you can pass as many arguments as you want, but it will work. So this is a very simple example where I'm using that each individual elements and greeting, but it can be anything. So think of it like print statement. When you say print statement, so let me define some things. A10, B as 20, C as 30, D as 40, and as many as you want. All right. Now I can say print, and I should have made this strings because print actually takes strings. So let me make this a string. It can also take integer also, so no worry. So I can say hello, and print doesn't know how many arguments you are passing. You see, initially when we were talking about print, I was just saying whenever there is comma, space will come. Whenever there is plus, space will not come. All right. So over here you can see what this it is doing. So let me actually change this to integer only. My point will be clear. All right. So you see, this is the first argument, hello. The second argument I am passing a. The third argument I can pass good. the next argument I can pass B, again C, again integer or something doesn't matter, and D. Now you see print doesn't know how many arguments you are passing. So these functions actually use these keyword arguments, and not keyword arguments over here, arbitrary arguments, and then prints it. So this is how print statement works. A little bit, it's not very precise, but you see this is how it works. And inside print statement, it knows that whenever there are two arguments, I have to have a space in between those arguments. So using this idea, I can ask you, I can give you a project and say, make a print function, your own print function, and you have to take care of these things. It can take as many arguments as it wants. It has to have a space whenever two arguments are passed. The end value or the whenever the last element of that print will be a backslash n. These things you have to take care of, and the default value of end will be backslash n, and so on. Now there is something called sep. I have not talked about this. Something called sep, and what sep is, the separator. So when hello and a is being passed, the separator is space. When you change sep to say plus, so the two arguments will be separated by this plus. You see, let me execute this. So it is saying hello plus 10 plus good plus 20 plus 30 and so on. So this is also a default value. So you can pass these things and you can make your own functions. All right. So I just wanted to bring this up. Any doubt?
This change of this separator, this affects only for this print statement, right? It will not follow throughout the other prints following this.
No. This will only work for this. So you can just check. So these doubts are very good. You can just check and see what if it is. So you see, it is not changing. It is only for that specific print call, function call.
Okay.
Any doubt? You can also change end over here. So end has something, and you can do it something like double backslash n. So you want two enters. So you can do backslash n, backslash n, backslash n, 3 enters. And when you do, there are 1 enter and 2 more enters. Anything else?
No.
All right. So this is some important things I had left when we were talking about functions. So I wanted to take this up. Now there is the idea called recursion. All right. So I guess you all are familiar with this idea. If not, then I'll ask individually. Here, does anyone doesn't know about what recursion is? Pratibha, Ashok, Ranjit, ma'am. I guess ma'am will be clear. Ram Prakash. All right. So I'm not getting any response. So you see, recursion is actually breaking your problem in terms of that problem itself. So there is something in mathematics called mathematical induction. And if you are familiar of mathematical induction, you will know that what mathematical induction does is, it says that suppose one value or one expression is true for some value of n. So I have an expression in terms of n, and I'm saying that that expression is true for some value k, suppose k. And if I can prove that that expression is also valid for k plus 1, and that expression is also valid for some base case, then that expression is valid for all numbers. So this is how mathematical induction works. I should have written it somewhere and explained you, but we are not talking about mathematical induction, so I'm not going there. But what recursion is doing is, it is taking one problem and defining that problem in terms of itself. So you see, you can have a factorial function. So I can have a factorial function fact. So those of you who don't know what factorial is, so in mathematics factorial is written in like this, 5 exclamation mark, it means 5 factorial. And what factorial is so 5 factorial is actually, I know many of you may know, but let me write it clearly. So it is 5 into 4 into 3 into 2 into 1. So this is what 5 factorial means. You see, this is one definition of factorial. There is one more definition of factorial, which is a recursive definition of factorial. You see, when you write 5 factorial this way, you have 1 into 2 into 3 into 4. This can be written as factorial of 4. So 5 factorial is actually 5 times factorial of, so if I say fact of a number is defined as, so this, whenever I write fact of a number, so n, it means n factorial. So this is my definition of fact of n. Now I can say 5 factorial is actually 5 into fact of 4. So what does this mean? It means that you can write 5 factorial in terms of 5 into 4 factorial. It can be written as this way also, 4 factorial. All right. So 5 factorial can be written as 5 into 4 factorial. So you see there are two definitions of factorial. In one definition, you have expanded the problem. In the other definition, you can write the problem in terms of itself. How? You see, in the left hand side, you have fact of 5, which is equal to 5 times the fact of 4. And for any arbitrary number, fact of n, you can write n times fact of n minus 1. All right. So this is one example where you can use recursion. Now what is recursion? You see, you're using that idea or that function again with a slight change in the argument value. And in that way you are breaking down the problem. So what was the problem? Your problem was to finding factorial of n. Now you have broken down that problem into n into factorial of n minus 1, and how far it will go. So this is one part of that problem. You have not solved the problem. Why? Because you don't have a base case. It will subtract and go to infinity, minus infinity, but you don't want that because factorial here is defined for positive numbers. So you'll have to have a base case. What is the base case? You'll have to say factorial of 1 is equals to 1. Actually factorial of 0 is also there, which is 1, but that is not important here. So I'm saying this is the base case. Whenever we come n minus 1, n minus 2 till whenever we hit 1, we'll have the value as 1. And now it will follow back. So it will take factorial of 1 is 1, and then it will take for 2, and then it will take for 3, and so on. So this is the idea of recursion. Recursion is actually breaking down the problem into the definition of itself, but it will have a base case. If you don't define a base case, then it will fall into a infinite loop and your problem will crash. All right. So there are some advantages and disadvantages of recursion. You see, advantages of recursion is it makes your problem look elegant, you know. But and one more thing is you can think of at breaking your problem into smaller chunks. So you're having one big problem, but you're defining that problem in terms of itself and breaking down the problem. So these are some of the advantages of recursion, but the biggest disadvantage of recursion is it is very difficult to understand a recursive problem. So whenever you write a recursive problem, and if you have some bug in that problem, you will face a lot of difficulty in solving that bug. Why? Because in normal code, the flow is sequentially. You go line by line, and whenever there is some function call, you go to that function and then you check what it is doing. But in recursive calls, there can be hundreds and 200s and thousands of calls, and it is very difficult to keep track of that function call and then see where the error is. All right. So why I'm saying function call, you see, suppose you have defined some function called fact, which is trying to compute the factorial of n. And when I say fact n, it is actually a function call. And when I say fact of n minus 1, it is also a function call. So this function fact n is actually calling itself fact of n minus 1, and we will see this with an example. All right. So this is why it becomes very hard to keep track of where the error is. Now the second second important difficulty or disadvantage of recursive problem is it takes a lot of memory and it becomes very inefficient if not taken care properly. So what do I mean by if not taken care properly? We will see in in next class when we see one example with dictionaries and recursion. All right. Now let us see one example of recursion. That factorial function will see how recursive calls are there for factorial function, and it is, you see, it's not very difficult. So let me define a function called factorial. So this is actually a markdown cell. I'll do markdown. All right, just 1 minute. Just 1 minute. Yes. So let me define a function called def fact. So this is similar to what we are doing, and it is taking a number n. Now what it will return? It will actually return. So I'm just doing in one line, return. It will return n times fact of n minus 1. Now you see over here you are not defining any base case. You are just saying n into fact of n minus 1. So this you will have an error. Why? Because it will go infinitely till minus infinity. You have to have a base case. So I'll just do it in one line. You can also do it in more than one line. How you can do it? You can say 1 if, not if, it is if n equal to 1, else you say n into fact of n minus 1. I guess this will work. If not, then we can break this down. How will we break this down? We'll do that like this. If n equal to 1, then return 1, else return n times fact n minus 1. So you can do both this. I'm just commenting this part. All right. So this is what I have written in one line. It is saying return 1 if n equal to 1, else return n times factorial of n minus 1. All right. So this is what it says. Now we will call this function. We will call fact of 5. Fact of 5 is 120. We'll get 120. How it is doing? You see, first we'll pass 5. You can visualize this very nicely when you go to Python tutor. So let me do that, I guess, if you are interested. Should I go there or not? Hello?
Yes, sir.
All right. Thank you. So let me do fact of 4. All right. Now you see over here what it is doing. We have a sum function, so it is not worrying about the scope of that function. It is just saying that function is there called fact, and then it goes to the next line, which is fact of 4. Now it is calling this function, so it will go inside that function. I'm sorry. It will go inside that function. So this is the scope of that first function where n is 4. Now it will come to this line, return 1 if n equals to 1, else return this. So you see n is not equals to 1. So it will return this part, n into fact of n minus 1. So it cannot return n into fact of n minus 1 until and unless fact of n minus 1 is evaluated. So first it will evaluate fact of n minus 1. So it will go there. All right. So it will go to fact of n minus 1. So initially n was 4. It will go to fact of n3. So where n is 3. Now when it will check if n is 1, no it is not 1, then it will evaluate n into fact of 2, but fact of 2 is not defined, so it will go to fact of 2, because fact of 2 is not yet evaluated. So it will first evaluate fact of 2, then only it can return n into that fact of 2. So it will go there. So it will have another function scope. Now again n is 2, it will go to n of 1 because n is not 1, n is 2. So it will have 2 into fact of 1. Now when fact of 1 it is encounters, now this return statement, this if statement will be evaluated. So it will return 1. Now when it returns 1, this value which returns 1, it will come over here. It will have n into fact of 1. What fact of 1 returned? It returned 1. So it will have n into 1 in that case. Alright. So you see, return value is 1. It will return which function called it? This function called it. So this value will be returned over here. So it returns here. So it will now this function will return 2 into 1, which is 2. It will return 2 over here. Now this function will return 2 into 1 into 3. So it will return 6 and 24, and therefore all things has been done and it is executed. All right. Is it clear?
Yes, sir.
All right. So
Yes, sir.
yes. Fibonacci series. Let me skip this part. Fibonacci. Let me skip this part. I'll give you one assignment on Fibonacci. It's very similar to this, and moreover, we'll talk about Fibonacci when we will talk about how dictionary may be useful when we have recursion. In that case, you will see that dictionary makes recursive problem more efficient in some way if you use it for your advantage. All right. So I am skipping this part. Now there is very important functions called lambda functions or anonymous functions. All right. So what are lambda functions or anonymous functions? So let me first give you one example of lambda functions, and then we will see why it is known as anonymous functions. All right. So suppose I have a function called square. So you see, we had defined a function called square somewhere. What did function do? It took a number and then squared it. So how did we define that number, that function? We defined it as def square, and it took one number and it returned number to the power 2. All right. So this was the definition of square. Now you can use lambda functions to define square. So you see, we are naming it square. So over here, this lambda function is not anonymous, but it can be anonymous. We will see a little bit later. And I know it must be confusing what is anonymous and what is not. Just hold on with me and you will understand. All right. So I am defining this function square in terms of lambda functions. It is lambda. So this is a keyword. All right. So you should use LAMBDA, lambda. And you see, you can say a number or anything. This is a variable. So I'm just saying x colon, and the return value is x to the power 2. All right. So this is how this lambda functions is defined, and you can have SQ. So let me say square 1. Now it will be better. All right. SQUARE square 1, and you pass 7. And when you do, you see, you get 49. So this is a concise way to define functions. What it is doing is, this is the function name equal to lambda function x. So this is the argument, and this is the return value, which is, so this is how it is defined. This is lambda function, this is the argument, and this is the return value. That is it. All right. That is it. Now, why this is anonymous? Before coming to that, is this clear? This definition of lambda function is clear.
Yes.
Okay. So you see, let me make a list. List 1 equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. So this is a list, and I want to get a new list which is the even elements of this list. So I'll say even list is equals to, and I'll apply filter. So we have seen filter function. What it does is it applies one function to the elements of the list. All right. So how does it do? We will have filter filter, and the name of the function. I'm not writing the name right now. So this is the name of the function, and the list will be there. Iterable will be there. So this is the iterable. Now over here you have to give the name of the function, but what we will do is we will define the function over here, and in that case we have to use lambda function. We will say lambda, lambda x such that x mod 2 equal to 0. Now what we did is we defined the function here, so there is no need to give a function name, and that is why the function lambda function is anonymous function. Over here we did not give a name, and for better understanding I'll make this a list. You see, filter function, what it do is, in the first argument there should be a function, and in the second argument there should be an iterable, and it applies this function to each element of that iterable. Now instead of giving a name of the function, what we are doing is we are defining the function there, and lambda function is generally used for simple functions. If your function is more complicated, we generally don't use lambda functions. These are how we make our code precise. So Python is generally preferred for this only. So it makes your code less number of lines. It concises your code. All right. So in other languages this would have taken 10-12 lines, but over here you can do it in one line. All right. Now let us see if this is working or not. I have given you 10 minutes lecture on this, so let me check if I have written. Yes, so you see, when we applied filter, in 1 it gave false, so it did not return 1. In 2 it gave true, so 2 came, 3 false, 3 did not come, 4 true, 4 came, and so on. So 2, 4, 6, 8, 10. Similarly, you could have applied map. So if you apply map, and when you do this, so it will give. So you see here it is not changing. What filter is doing is whenever it is false, it is removing that element, but map is just applying this function and returning whatever the return value is. So map is returning false, true, false, true, false, true, false, true, and so on. All right. Now for map you can think of some other functions also. Suppose for each element of the list I want square of the number. Square of the number. So map is not generally used for true and false, but I had defined filters, that is why I had used this modulus of 2, but I can say this. So new list, you see, it is taking individual element of list 1, 2, 3, 4 and applying this function lambda function over there. So 1 square, 2 square, 3 square, and so on. All right. So see, lambda functions are used a lot in Python, but it is generally used in simple functions. So we generally don't write very complicated functions in lambda functions. All right. Any doubt?
No, sir.
All right. So modules. Let me take this in the next class. I guess we have discussed a lot, and in the next class we will proceed with modules. All right. So I'll take the attendance. Before that, do you have any questions? Is everybody here?
Yes. Next class will be on Monday, right?
I'm not sure actually. This till Diwali I am very booked. So I will try to take that class on Monday. I will try. 90% the class will be there on Monday at 6 p.m. So I'll message. I'll message in the group or email you the timing for sure. All right. So I'll be less frequent in these 2 weeks till Diwali. After that, I'll be sincere, if that is what I meant. Yeah. Yes. So please tell me your names. I guess.
Kalaivani, sir.
Yes, ma'am. Ram Prakash is here. Ranjit is also here. Pratibha is here. Hello, Pratibha. Are you here? I saw Pratibha here. Is she here? Yes. Pratibha is here. And who else? Ranjit, I marked, no? Yes, I marked. Who else? Ashok Vardhan. Hello, Ashok. Are you here? Where is Ashok Vardhan? All right. Thank you. So I guess 5 people are here, no? Yes. Thank you for joining today. If you have doubt, you can be here or you can leave.
Thanks, sir.
Thank you, sir.
Thank you.